Welcome everybody to the third video in our computer-aided manufacture playlist. The next step we're going to do is actually start creating some codes. Now we are going to start with the drill code. The drill code, as the name suggests, drills out some holes. When you first select it, the first thing you need to do is select on the two axle holes we want to drill out. And from here we're going to start doing the very critical process of defining the tool that we're going to be using. I use a 6mm ball mill, so having done tool and select, I need to create that ball mill. I also need to specify the speeds and feeds that I'll be using on our machine. So for example, our spindle speed for the 6mm ball mill is 23,000 revolutions a minute. Our cutting feed rate is 4,000, our lead in 4,000, so on and so forth. Our plunge feed rate is about 1,750. So that's what we do there. I'm now going to change over to general, and I'm going to call this the F1 6mm ball mill. The cutter details I need to change as well, so 2mm, clockwise is right, it is high-speed steel, we don't want coolant. The flute length is 38, the shoulder length is 48, the shaft diameter is 6, the tip diameter is 6, the body length is 48, and the overall length is, I just usually go somewhere around 60. And that's about it. That's all we've got. So we click OK on that, and then we click OK again, and you'll see you now have this fixture, this drill bit with a collet on it that is primed and ready to go above the start line here. So let's start. Let's click OK on that, and let's simulate that code that we've now created. You can see how it's underneath the left setup. Simulate, I'm going to turn stock on, turn toolpath onto trail, so I just see it after it's been used, click start. I'm getting an error here. See how it flashes red? The error is because my drill, and I'm going to edit the code by right-clicking edit, the height of the hole is all the way down here in the stock, and it's doing that early on, and it thinks that it's moving too fast through the stock here. It's not actually, but it thinks it is, and so it's throwing an error. To turn it off, we change the top height here from hole top to stock top. Click OK. And we also make sure that our bottom height is on the origin and -4mm. Very critical that, because it needs to go just beyond the hole. Other than that, retract and clearance height should be as seen here. If it's not, just pause and change them. Click OK. Simulate again. Play. No red flashes this time. Looks like we've got a good drill code. So I'm going to click OK on that. The next code I'm going to create is the parallel code. So I'm going to go to 3D parallel. The 3D parallel code is slightly more complex, and we're going to just create it at this stage and have a look at how it works by making sure that the geometry is correct. So clicking geometry, rather than the silhouette, we're going to go selection as the limiting boundary for our code. We're going to use that vertically inclined sketch box that goes across the front of your design and goes through top to bottom of your car. Having clicked that, I'm going to turn off contact only, make sure that tool containment is on center, and change the additional offset to 2mm. I'm going to change now heights. I'm going to make sure that again the bottom height is not bottom but the origin -4mm. Your teacher should hopefully explain the reason for that and the reason that we have to make sure that we go past halfway. The stock top is the top. The passes I'm going to leave as is for now. Clicking OK, it should simulate a code, and there's our parallel code. Simulate, play, we'll run it at fast speed. I've got a couple of little errors there. Something's going wrong on that end. Probably the speed at which it's moving up and down inside the block, yep. And then also, if we look and zoom in on our vehicle, we have got a horrible vehicle. It is not looking good. It's not looking good at all. So a couple of issues here. First of all, the pass direction is pretty standard and not very well designed for this, because it doesn't do a good job of any of the horizontal surfaces that are slightly inclined. So that's one. And number two, the distances between the passes are absolutely ginormous. If you look at the gap between those two, they're quite large, the gaps, for a 6mm ball mill, and so we're going to modify that quite a lot right now. Just also noticing the cutting feed rate, that should be around 3,000 millimeters a minute. And that is especially important because we're going to be putting in a adaptive code to remove most of the material in the next video. Moving back to passes, I'm going to change my pass direction to 45, and I'm going to change the step over to 0.6 because this for us will be a finishing toolpath. Other than that, click OK. And if you look at the code now, it's so much more fine. And if we simulate that just to start it, and we zoom in the speed, you can see now the detail that you're getting out on your final model is exceptional compared to where it was before. And also with the 45°, we don't have any of those errors in the code anymore. That's a win-win-win for us and our code. Let's save what we've gotten done so far, and I'll see you in the next video. Good job, and thanks for watching.